Now we move to the next section where we will revise elementary algebra rules and formulas. Algebra is focused on terms and the rules surrounding their manipulation. Terms are expressions that can include numbers, variables, brackets, as well as many other different operations. So we will start with powers. So a real number to the power of n, where n is a natural number, is just a multiply to itself n times. In particular, a to the power of 1 is just itself. And for example, 2 to the power of 3 just will be 2 multiplied to itself 3 times, which is 8. The power rules in more details will be covered in the next chapter. So here we just want to overview powers. Next important rule that we will cover is commutativity. The addition and multiplication of real numbers are commutative. What it means? It means that, for example, if we take 2 plus 3, it equals to 3 plus 2. Or if we take 2 multiplied by 3, it will equals to the 3 multiplied by 2. It's very easy to check. We can just calculate separately this part, which is 5, and this part is 5. So, and here we will have 6, and 3 multiplied by 2 is also 6. So this is a commutative rule of addition and multiplication, but very important. It's not the same for subtraction and division because they are not commutative. For example, 2 minus 3 is not equal to 3 minus 2. You can see what I'm saying because 2 minus 3 will be minus 1 and 3 minus 2 will be 1. So minus 1 is not equal to 1. So this commutative rule does not apply to the subtraction. Same for division, like 2 divided by 10, it's not the same as 10 divided by 2. So it's not true for the division as well because this will result to 0.2 and here we will have 5. Two different numbers, right? So please don't mix them up. Next rule is associativity. So associativity means that if we multiply or add numbers one after another, it doesn't matter in which order of operation is performed. If we replace ABC with the simple numbers, let's say 2, 3, and 5, it's 2 multiplied by 3 multiplied by 5. So this is the same as this. So it doesn't matter if we multiply 2 and a 3 first, which will be 6, or 3 and a 5 first, which will be 15. In both cases, we're going to have the same answer. And same goes for the addition. We can have 2 plus 3 plus 5, and again 2 plus 3 plus 5 here. Let me divide it like this. So it doesn't matter if we first add this 2 or this 2, it will be always the same answer. Here will be 5 and then we will have 10 in the end, or here we will have 8 and again the same answer. So the order of operation for this case doesn't matter. Next rule is distributivity. So distributivity means that, for example, this rule here shows that, for example, if we take 3 multiplied to 5 plus 2, so we can distribute it and rewrite it as 3 multiplied by 5 plus 3 multiplied by 2. These both are the same. Why? Because we can also calculate it separately, like 3 multiplied by 5 will be 15 and 3 multiplied by 2 will be 6. And 15 plus 6 is 21. As for here, 5 plus 2 is 7 and 3 multiplied by 7 will be also 21. And you can see here, if we change the order here and here, it will also be the same. We can also exchange them. And if we, for example, have two brackets, they are equal to this expression. It's very important to remember that as a minus b is equal to a plus minus b, if we have a subtraction here, we can also use associative and distributive rules accordingly, because we can replace a minus b with a plus minus b. The only thing we should not forget about this minus sign and keep it along the expression. For example, a quick example we will have here. Let's say we have a term that we want to simplify, for example, 2 plus 2x minus 3 and minus x. So by the help of this associative rule, we can group terms with the letters together and the numbers together, but not forget the signs. For example, 2 minus 3, or we can also say 2 plus minus 3 plus, we group 2x minus x together. So we can perform now basic operations here and find out that it will equal to minus 1 plus x. So this rule applies both for associativity and distributivity property. With the help of distributivity property, we can come up with very important following binomial formulas. Let's have a look at the first formula. How did we come up with this formula? I will try to explain to you. So a plus b to the power of 2. So if you remember the power rule, it means that it's just a plus b multiplied to a plus b. By using distributivity property, we can also rewrite it as a multiplied to a plus b plus b multiplied to a plus b. And then we use distributivity property again, and then we multiplied them both here and b here. And then we will get a square plus ab plus ba plus b square. And because of commutativity, AB and BA are the same. So we can rewrite it as a square plus 2AB plus B square. So this is how we came up with this formula here. You can try to deliver other two formulas using the same strategy. I would recommend learning these formulas by heart because you will see and use them often in our course and in your studies as well. So I have some good news for you. We arrived at the last part of chapter 1, where we will refresh our knowledge about fractions. Good job! We will start revising fraction first with expanding and simplifying fraction. Expanding a fraction means multiplying the numerator and denominator by the same non-zero real number. For example, let's take fraction 4/7 and multiply numerator and denominator by 3. We take number 3 here and number 3 here, and we multiply, and we will have 12 in numerator and 21 in denominator. And by multiplying, we will end up with a new fraction. This is called expanding a fraction. On the other hand, simplifying means dividing the numerator and denominator by same non-zero number. For example, by looking at this fraction, we can divide both parts by 2 and rewrite it as 4 multiplied by 2 and 7 multiplied by 2. So we just divide it by 2 and end up with 4/7. The value of the fraction doesn't change by simplifying or expanding. That's why this fraction and this fraction and this fraction here, they're all the same. If we rewrite all these fractions in decimal form, we will end up with the same number. If we cannot simplify further, like 4/7, then this fraction is called a simplest form of fraction. Let's revise the fraction operations. So two fractions can be added or subtracted easily if they have the same denominator. For example, let's say 1/4 plus 2 fourths. And in this case, the numerator will be just the sum or difference. In this case, sum, which is 3 fourths. Tricky part comes when two fractions have different denominators. So for that, there's a rule how we can easily make a new denominator. For example, we have this fraction plus 2/3. So in this case, we can just multiply 2 by 3 and then add as a multiplication here 3 and here 2. And then we will end up with an expression where we'll have 3 multiplied by 1 plus 2 by 2. And here we will have 3, 6 plus 4, 6. And this will be 7, 6. It's easy to do when we have like the small numbers here, and when we have a larger numbers, it is not very convenient to do it all the time, just multiplying the denominator to each other. Better just to find the lowest common denominator for both fractions. For example, let's take these two fractions. As you can see, we have 1/16, and you can easily see here that if we multiply 8 to 2, then we also get a 16. So we can expand the fraction 3 multiplied by 2 and 8 multiplied by 2. So this will be the same fraction as we saw before on the previous slide. And we will end up with a new fraction. It's 1/16 plus 6/16. And the answer we get will be 7/16. So this is the answer. And same goes for the subtraction. The multiplication is much easier than addition and subtraction. Here, we just multiply denominator with denominator and numerator with the numerator. For example, so in this case, as we just multiply 3 by 2 and 4 by 3, we get 6/12. Or we can go and further simplify by dividing both parts by 6. As for division is a little bit different. As you can see here, we swap numerator and denominator of divisor, and then we multiply them. So 13/15 divided by 2/7, we leave the first fraction as it is, 13/15, and then we put the multiplication, and the second one we swap. And by multiplying 13 by 7 and 15 by 2, we will get our final result as 91/30. So, congratulations! This is the end of chapter 1, and see you in the next chapter.